solution to example 3b from our notes on 6.5. It's a second example of a tangent function that we didn't have time to complete in class. And it's a transformed tangent function. We've got y equals -2 tangent to x. So we're going to think about the parent function for tangent and see how these transformations will affect the new graph. So the first thing I want to do is figure out where the vertical asymptotes lie. On the parent function for tangent, I need to remember that in that base period, the vertical asymptotes lie at plus or minus pi over 2. These are the values where tangent is undefined. In this function, our input isn't x, it is 2x. So the equation that I want to solve is now when is 2x equal to plus or minus pi over 2? And that's going to be multiplying both sides by a half. X equals plus or minus pi over 4. Those will be our vertical asymptotes. Second way to think about the vertical asymptotes, if in the base function, parent function, vertical asymptotes are at plus or minus pi over 2, this function, multiplying x by 2, is a horizontal shrink by 1/2, which means those vertical asymptotes are going to come in by a multiple of 1/2, which will put them at plus or minus pi over 4. To find the period for the parent function is pi, so the period for this function is going to be pi over b, where b is the coefficient of x, so it's pi over 2. Second way to think about the period, it's the distance between the vertical asymptotes. So the distance between negative pi over 4 and pi over 4 is pi over 2. Key points when I do my x scale, or I can just say the x scale, I want to set it at the period over 4. So in this case, that's 1/4 times pi over 2. So I want intervals of pi over 8 for my x-axis. That will be helpful. And then let's transform those three key points. So we had negative pi over 4, -1, 0, 0, and pi over 4, 1. On sine and cosine, we only transform 1 point. On tangent and cotangent, it's helpful to transform 3 points. These are the 3 points for tangent. And let's see what's happening to x values. X values are going to be multiplied by 1/2. And if we think about transformations, this is a horizontal shrink by 1/2. And y values are going to be multiplied by -2. And we have two transformations that are going on here. We have a reflection in the x-axis. And the second thing we have is a vertical stretch by 2. Vertical stretch by 2. So if you ask for transformations, that's what you would say. If we want to know what happens to the points, we have that here, just what we multiply by. So multiplying x by 1/2 here, that's going to give us negative pi over 8, -1, and then multiplying y by -2. Let me fix that, -1. That doesn't look so good. So I'll rewrite that for us. Negative pi over 8, -1. Multiplying y values by -2 puts this point at negative pi over 8, 2. 0, 0, multiplying x by 0, I'm still at 0. Multiplying y by -2, it's still at 0. Pi over 4 times 1/2 is pi over 8, 1, and times -2, 1 times -2 is -2. So pi over 8, -2. Those will be our key points. Let's set up our x-axis. Like we said, intervals of pi over 8. So I'm going to count by pi over 8. So I'm at pi over 8. I'm going to do 2 squares as pi over 8. 2 pi over 8, which I'll simplify to pi over 4. 3 pi over 8 can't be simplified, so I'll write that. 4 pi over 8 simplifies to pi over 2. 5 pi over 8, I can't simplify that. 6 pi over 8 simplifies to 3 pi over 4. And then we'll write similar points in the negative direction. So negative pi over 8, negative pi over 4, -3 pi over 8, -4 pi over 8, which is -pi over 2. Axis, I'll let 1 square be 1 unit. And will go ahead and mark that off. So 1, 2, 3, negative direction, -1, -2, -3. And that's put on our vertical asymptotes. We found those in kind of the base period at x equals -π/4. And then in the next one was x equals π/4. And to find another vertical asymptote, because there's an infinite number of them, I can add a full period. The period is π/2, so π/4 plus π/2 is the same thing as π/4 plus 2π/4, which is 3π/4. So I'll sketch in one more vertical asymptote. And now we're ready to put on those key points. So we had -π/8, 2, 0, 0, π/8, -2. And we'll sketch a nice smooth curve as best we can through those points. You notice this is a reflected tangent function, so it's actually decreasing in each cycle, which is what we'd expect. I'm kind of going to copy this over into the next cycle. So 3π/8, 2, π/2, 0, 5π/8, -2, and once again, have the graph shoot towards those vertical asymptotes, going down to -infinity here and up near the π/4. And we can copy that over into one more cycle if we'd like. And so we would have this at this would be the part that's going down here. So this would be -3π/8, -2, and -π/2, 0. And we'll sketch that